Imagine rewriting a single Bitcoin transaction from 2013, not stealing a key, not hacking a wallet, just quietly changing one entry in the ledger. To pull it off, you'd have to redo every block of computation since roughly a decade of the world's most expensive arithmetic. Here's why. The Bitcoin blockchain is an ordered, backlinked list of blocks. Each block holds a batch of transactions. The structure is humble. It can live as a flat file or a simple database on every node. But the ordering matters. Blocks aren't a set. They're a sequence. Every block knows exactly which block came before it. And that knowledge is baked into its cryptographic identity. That single design choice is what makes history hard to rewrite. Picture a stack. The bottom block is called the Genesis block, sitting at height 0, the foundation Satoshi laid in January 2009. The block at the top is called the tip. Height measures distance from Genesis. Today, Bitcoin sits above height 800,000. New blocks land on the tip every 10 minutes or so, raising the stack. Genesis at the bottom, tip at the top, height counting upward. Hold that mental image. It's the geometry that gives Bitcoin its security properties. Every block has a unique identity, its hash. That hash comes from running SHA-256 twice over the block's header. The header is a small fixed-size summary containing metadata, including one critical field, the previous block hash. That field stores the parent's hash. So a child's identity literally depends on its parent's identity. This isn't a soft pointer like a linked list. It's a cryptographic commitment. Change the parent by a single byte, and the child no longer points at the same thing. Watch how a node extends the chain. Suppose a node sits at height 277,314. Its current tip has hash ABC.123. A new block arrives over the network. The node opens its header and reads the previous hash field. The value reads a BC.123, an exact match for the current tip. The node accepts the block, snaps it on top, and advances to height 277,315. That handshake, prev hash matches tip, is how the chain grows, block by block. Now the cascade. Suppose an attacker wants to alter a transaction in an old block. Changing any byte changes that block's header, which changes its hash. But the block sitting on top of it stored the old hash in its own header. That child's hash is now wrong too. Its child, wrong. And so on all the way up to the tip. To make the tampered chain valid, the attacker must recompute every block above the change, redoing all the proof of work in between. One altered byte forces a complete rebuild of everything that came after. That's the cascade. Sometimes the chain temporarily splits. A block has exactly one parent, but it can briefly have two children. When two miners find valid blocks within seconds of each other. This is a fork. Different nodes see different tips. The ambiguity resolves quickly. Miners keep building, and whichever branch gets the next block first wins. The other branch becomes orphaned. Its block is discarded, its transactions return to the pool. Forks aren't a bug. They're a routine self-healing feature of decentralized timing. Think of geology. Surface sediment shifts with every gust of wind and every footstep. A foot down, things settle. 100 feet down, you're looking at a snapshot millions of years old, essentially untouchable without massive excavation. Bitcoin works the same way. The tip is fluid, forks reshape it constantly, but each block of depth adds a layer of pressure above the ones below. Deep history becomes practically frozen, not because the laws of physics forbid changing it, but because the energy required grows with every layer stacked on top. The network turns depth into specific thresholds. After a block sits 6 deep beneath the tip, the convention treats it as confirmed. Reversal becomes vanishingly improbable, which is why exchanges and the payment processors wait for 6 confirmations on large transfers. There's a stricter threshold for Coinbase transactions. the special transactions that pay miners their block reward. Coinbase outputs can't be spent until 100 blocks have been mined on top. That 100-block maturity rule protects against short-lived reorganizations near the tip that could otherwise erase newly minted coins. Depth becomes policy. This isn't security by impossibility, it's security by compounding cost. A longer chain can always, in principle, overwrite history. Bitcoin doesn't outlaw it. It makes it economically absurd. Each block layered on top adds another slab of computational pressure to the record below. The probability of reversal decays exponentially with depth. After 6 blocks, you'd need a sustained majority of global mining power. After 100, you'd need to outrun roughly 17 hours of the world's hashing. Bitcoin replaces institutional trust with arithmetic. Not a wall you can't climb, a slope that gets steeper with every passing block until rewriting the past costs more than the past is worth.